For my Milestone 3, I was in charge of putting together an enclosure, which for Milestone 2 I showed a SolidWorks model of this enclosure since we hadn't received all the materials yet. But as you can see here, we now have it up and running. So all of our components that were previously scattered all over the lab are now housed in this nice metal box that can be rolled around, and also provides some convenient connections for all the motors, the e-stop, and eventually we'll be punching holes once we know exactly which board we're going to be using. So everything can be hooked up like a standard PC. Inside here you can see the different stepper drivers as well as the power supplies, the main breakout board, and the new board, the Ethernet smooth stepper here, which is now running on the Windows 7 PC per Sandia's request. So this board actually has an FPGA and a microprocessor on it, so hopefully that'll give us some abilities in LabVIEW as well later down the road. So right now it's just in a standby mode since Mach 4 is not running, just to make sure that there are no output signals being sent. So what I've got here is I've got our enclosure here set up. The mechanical engineers have wired it up so that the X and Y axes can move, and the Z is just a fixed arm right now since they're still working on that. And for this little demo, what I'll be trying to do is just scan this small white box just to show that we can get some displacement measurements as the arm moves around. We are not yet to the point where we can just put an object in and start scanning, but we still have to kind of create like an XY grid and then take measurements, line them up with the XY grid, and form a mesh from that, which is what Tayson has been working on. So over here on the computer I've got Tayson's LabVIEW VI open that will take measurements from the laser sensor. We've got right here the measurement delay, which is just how long it takes for the arm to move from position to position to take a measurement, and then where this file will be output. The Mach 4 demo is limited to about 15-20 minutes, so there's a good chance that this will max out of time before the actual scan finishes, since it's still kind of slow right now. But I'll go ahead and open up Mach 4. So Mach 4 can communicate with the Ethernet smooth stepper loaded up right now. We'll zero out the axes to say that's where we want to start. So loading in some G-code that 2 wrote. This G-code just moves the armature back and forth in a grid pattern and stops and pauses for about a second in each position so that we can get some measurements. So go ahead and get that running. We'll first enable and then actually start. So this will take a measurement each time there's a pause. And you can see the measurements recorded here on the displacement chart. And what this is doing is just scanning back and forth. You can maybe see the laser if I get close enough. And it's just taking a distance measurement. This laser is only operable between 190 and 110 centimeters, so we have it set right now to about 170, and it'll just measure to the plate. And then when it turns back around, it'll start measuring the box. And to fast forward this, since you probably don't want to watch that scan for 15 minutes, if we come in here, I'm back on the computer while that's running. This is one I just barely did a second ago. This test XYZ is the output of the LabVIEW file. Go ahead and stop that since it's really loud. Alright, so if we open up Mesh Lab, in here we can actually import the XYZ file. So right here we have the test one that I did just a moment ago, and what it gave us is some grid points. It looks just like a flat grid until you start rotating it around, and you can see here the outline of the box perhaps of where it was. kind of a rough sketch there, but you can see the displacement measurements in the area of where the box is. Since I'm trying to start both programs at different times, the measurements get a little bit off from our grid. Worked a little better when we actually had two computers, so we could click them both at the same time. But so yeah, that's the goal, is to get this all automated so that once we get it put together, that LabVIEW will just know where the laser sensor is and compute those. We can do a continuous scan where the motor will run constantly. And that is my Milestone 3.